Hello, Houston. We're talking today about, or we're finishing our talk today about perceptual processes and looking specifically as our first topic today about depth perception, how we go about perceiving depth and, as it turns out, a related topic, distance. Depth perception is the topic that's at hand, and it turns out there are a number of different cues that we end up using. Some of them are features of the stimulus itself, that is external to you and I, dealing with features of the stimulus itself, and part of it is internal cues, features of you and I, which we'll get into here a little bit later. But let's review, first of all, some of the external or stimulus cues that we use when we're judging things like distance and depth and so forth. Number one among those cues is size. All other things being equal, we do not tend to think of this guy as having a massively overdeveloped hand, as we talked about it the other day. We simply make allowances for the fact that it's projecting toward the camera and that therefore it is in fact bigger. So in this case, distance is reduced. That is, because the hand is so big, we infer correctly that in fact he's holding his hand closer to us than any other part of our body. So size is one thing. All other things being equal, you will use size as the primary judge for closeness. And therefore, in looking at these three triangles, you tend to think of the center one as being closest to you simply by virtue of the fact that the line is fatter and the triangle is bigger, and that the second one on the right is slightly further back and the one on the left is the furthest back. And because you don't have any other depth cues, you're doing that strictly on the basis of size, which is one of the elements that we do use in judging the nature of the distance of an object. A second factor that we also use has to do with interposition. Interposition turns out to be a very powerful cue to judging depth and distance. For instance, here, if we look at this ball of yarn, I can ask you which strand is actually closer to you, and there are actually two candidates, and we can't really tell between them. The arrow, my pointer, is kind of small, but one is the middle of the three strands that goes from top to bottom on the screen, the one where the pointer now is, and the other possible candidate is over here. We would probably tend to use size to infer that this one, the center one, is actually the closest of all because it is slightly bigger in cross-section than is the one over here. But certainly between this one and this one, we can very quickly decide that it's the right hand of the two that is closer to us because we can see the whole thing. Another way to illustrate that is to do this. If I hold my hands up in this way, this arm is obviously closer to you because you can see all of it, whereas this one is interrupted partway through. I don't have a demonstration for it here because it doesn't work too well on television, but there's a very simple trick that you can do. I'm going to turn around and let you look over my shoulders for a minute. If you take two playing cards, basically, and lay one on top of the other and then cut the outline of the edge of the card, okay? So you take this playing card, trace the edge of it, and then just cut that out. So you've now got a kind of an L-shaped card here. If you then hold them this way, with the right hand one being much further back, and line up the corner of this card so that it exactly fills in the notch that you cut in this card, and then line them up this way, this one will actually seem to be about the size of a postage stamp. I mean, you're holding what you know is a playing card, but the one that's further back, because it fills in the notch, your system incorrectly infers to be the closer of the two objects. Since it is closer, it has to be about postage stamp size to do that. It's a bizarre effect that you nonetheless can get very effectively on your own, using your very own body. A third cue is shadows. Shadows turn out to be very important pieces of information for you and I in terms of judging the size and depth of an object. There are actually two different classes of shadows that we can talk about. One is what are known as attached shadows. Those are shadows that are directly attached to the object we're trying to judge. And the other is what are called cast shadows, those that are cast by the object itself. Both of them are represented on this particular object, and if you look at it, it doesn't take long at all to infer that this is a cylinder which is projecting outward from the wall to which it's attached, and that is a correct interpretation. The key point, however, is look at the shadowing on the, well, first of all, on the cast shadow, the one that the fixture casts onto the wall, notice over on the right-hand vertical edge how soft that shadow is. That is a hint to the fact that the surface that cast it is rounded. Okay? Contrast it with the shadow on the bottom of the fixture, on the bottom left side of the fixture, which is a harsh shadow. It's a sharp line, and that tells you that the end of the fixture is in fact sharp. It's not rounded. it is actually sharp. This is confirmed if you look at the attached shadow, and that is the one which is right as part of the object itself, on the right-hand side of the fixture itself. And you'll notice that the shadow line running right up the middle of the fixture is itself also soft. So we've got double confirmation of the fact that that surface, the surface that's facing us, is in fact a bent surface. And we're using there the attached shadow on the object itself, as well as the cast shadows further back on the wall. Both of those then are instructive in terms of the nature of the object itself and what parts are closest to us. Another one that we can use, which you may not be aware of, is what's called texture density gradient. Texture density gradient is essentially the gravel road phenomenon. You're looking here at the Temple of the Moon just outside Mexico City, and you'll notice down in the lower left corner of the screen, you can see the elements of the grout between the various rocks very easily. You can see details within the grout. 5 or 10 feet out, you begin to lose the details in the grout, and 10 or 15 or 20 feet out to the right, you're losing all detail in the grout. In fact, you can't even see it. And when you look at the rocks, you can pick out individual rocks up close to us here in the bottom left, but the further you go to the left, to the right, and up, the less detail you have on the individual rocks. And you can confirm that loss of information by looking at any of the rocks that are jutting outward from the edge of the temple. Each of those rocks is about half again the size of a football. So they're almost boulders rather than rocks. But you can see individual detail, certainly on the first two. But if you look over to the right, those things gradually become smaller and smaller and eventually almost fade into the side of the temple itself, so that you're losing detail the further away you go. I'll show you another example of that a little later, but that is what's called the texture density gradient effect. The further away an object is, the less detail we have in terms of being able to actually interpret the object itself. Another cue, and quite a powerful one, is what's called aerial perspective. There are two different forms of this. One is natural and one is human produced. The natural one is what's referred to as bluing. Do you actually have an E in bluing or not? I couldn't decide, so I went ahead and put it in, but put brackets around it. If you don't like it, we'll remove it for you. Aerial perspective, or bluing, is represented in this photo, and this may or may not project well on television, unfortunately, because you may have to adjust the lightness on your set to make this one work. But I'm standing in North Carolina looking across the top of the Smokies into Tennessee. And if you actually can fine-tune it, you will find, and I'll put the pointer up here and see if you can see it, there is one mountain ridge here, which is actually not the backmost ridge. The edge of it is there. There is a second ridge back there, so we've got 1, 2, there is a third one here, that's 3. There's a fourth one. There's a fifth one about here. There is this ridge which projects down here, and there's one even closer down in this area, which I'm sure you can't see. But in essence, what you're using there to make the discrimination between those ridges is primarily bluing. That is, the further away an object is on an otherwise clear day, which this is, the bluer the object tends to appear. And so certainly over longer distances, aerial bluing is a very powerful perspective. A number of years ago, I was driving to New Orleans on Interstate 10, and I got off on the causeway that goes over the Chefalaya Swamp, and there is a place where you can get down between the two causeways, between the two bridges. And if you take a photograph along there on a day like I did, what you end up with is an illustration of another cue, which is aerial graying. That's a human-produced clue called pollution. And in fact, on that particular day, those two bridges literally faded into the muck. You could not see the end of the bridges. That is, before other cues like aerial perspective kicked in, the bridge just literally disappeared into the pollution which was in the air that particular day. So whether we call it aerial bluing or graying, in both cases it's variations on what we would call aerial perspective. And specifically in that case, we're using a human-produced clue called graying. Both of them are very powerful cues, particularly for judging longer distances in the environment. Another very powerful cue is linear perspective. Question for you. If I'm standing in Maryland, taking a picture here across the Potomac River, what state am I looking into? Stunned silence. Virginia actually is the second best bet, but I'm up by Harper's Ferry, which means it isn't Virginia. See, this is why we now require geography in high school. No, it's north of Washington, D.C. Another good guess, No, it's West Virginia. You can actually see it right on the picture there. The sign on the bridge says West Virginia. Okay, so we've given you the answer right up there. Again, texture density gradient isn't going to allow you to enjoy that, but linear perspective is what's illustrated in this particular picture. You'll notice, for instance, if you take the top of these protector rails or even look at the rails themselves, you will notice that their width gets progressively narrower the further across the bridge you look. And in fact, in this case, these parallel lines are actually going to disappear about where my pointer is, if you can see it on the screen there. Right up about there is where all of these lines are going to disappear. And that is, in fact, how an artist achieves perspective. You put a disappearance point on your diagram, and then everything you draw points toward that and gives you the feeling of depth as you can experience it here. You also have texture density gradient because you can see the details on the individual ties, and you have the interposition effect because the ties progressively overlap each other. So you've actually got three different cues, but I think linear perspective is the most powerful one in that case. Here's a case where psychology disagrees with math, for instance, because mathematicians keep trying to convince us that parallel lines don't meet. Here is perfect proof in psychology that parallel lines do meet. In psychology, anyway. Don't harass your math instructor, they'll get flustered. Here's the Transco Tower. I believe they now call it the Williams Tower over in the Galleria. I hated that building when it went up, but the longer I've watched it, the more I like it. It really has an amazing variety of moods that it reflects as the environment around it changes. But here, you're looking right up the side of the building, and as you know, that building runs to about 70 stories high, so you're looking quite a distance here vertically. You'll notice on the individual windows, there is a large bar, if we can call that. That's a floor. The large bar above it is the next floor, and so forth up the diagram. There is a smaller band at each window. Probably, I would guesstimate, maybe 2 feet off ground level. So there are actually 2 windows per floor. You'll notice about 4 or 5 floors up, you lose the individual bands of the windows. And 6 or 8 or 10 floors, 20 floors up, you lose the bands for the windows themselves. What you're seeing there is a texture density gradient effect, and there's a very powerful linear perspective that is reflected in that diagram. For instance, and I don't know whether you can see the pointer, but essentially this wide angle from this point to this one up at the top is represented just by that little gap at the very top. So you have a very powerful collapsing effect that occurs in linear perspective, which is a very powerful cue to depth. And finally then, blurring. Blurring is basically one of the most interesting cues that we have because you and I control it. If you look at me, then the person in front of you, either in the lecture hall or at home where you're viewing it, blurs. So if you look far away, the intervening objects blur. If you look at the intervening objects, then the distant objects blur. So in fact, you can control it. In the diagram here, the person taking the picture is focused on the instructor, as we hope you are, of course. And that means the person immediately in front of them is blurry. But they could just as easily focus on the person in front of them, and then the instructor is blurry. So this is one that we can actually control ourselves. And this gets into the second broad cluster of clues that we're going to look at, which is essentially the internal or organism-based cues, of which there are several. One of them involves muscles, and to a certain extent, what we've just done is what's called accommodation. Accommodation basically is what the lens is doing when it focuses an object. If you rely strictly on the lens, you're relying on accommodation. It's a little bit misleading to call that a muscle cue because it is a cue if you're looking at a distant object when you have to shorten the ciliary muscles to flatten the lens. In this case, when you're looking at an object close up, you're relying on the elasticity of the lens to fatten it. So accommodation is partially muscle cue that's involved. The other one that is purely muscle cue is convergence. That's what happens if you hold your finger out in front of your face, focus both eyes on it, and then try to bring it in closer and closer and keep a clear image. The pressure that you feel in your head is resulting from the eye's attempt to converge, that is to focus inward on an object which is very close. Those muscle cues are a particularly powerful cue for us when the object is close. Further away, the difference between looking at something a quarter mile and a half mile away has essentially no detectable impact at all on convergence cues. There's a second group, however, that we can also look at, and those are what are called parallax cues, which actually come in several different forms. One of these is what we call retinal disparity. Let me give you an example of what I'm talking about there. If you hold your finger up directly in front of your face and snug it in as close as you can and still focus on it, looking at it with both eyes converged on it, alternately close your left eye and then your right eye, your left and your right, and you will get a very graphic example of how different the view of the eyes can be, of how different the views of the eyes actually are in that situation. That's an example of retinal disparity. The fact that the two eyes are getting very different views of the world, and that retinal disparity is actually the basis for. And I always block on the name of it. What is that device that gives you a picture, a frame of pictures that's about that big? You drop it into a little black thing, and you move the handle, and you get a stereo picture. It's a stereopticon. That's not the. What's the technical name for it? Spectrovision, something like that. Viewfinder, Viewmaster, that's it. Thank you. I feel I need to put it in my notes. But in any case, that one does give you a true three-dimensional image. And the way it does it is it gets control of where your eyes are looking. So when you look into that thing, your two eyes are looking at different photos. If you've ever taken the time to take the disc out and look at it, what you've actually got are two photos that are right side up, and right next to it, above it and below it, are two that are upside down. That's the reason you have to move the handle as far as you do, because you actually have to rotate two pictures worth so that the next set of pictures are exact parallels. The camera is normally accentuated. It's about a foot, maybe even 2 feet apart to take the picture. But you then look at those two images with separate eyes, and by blocking where each eye looks, they can in fact give you two separate images, and the brain senses it and will fuse the two and give you the three-dimensional images which we can get with both eyes. That's also the basis for the computer prints that you may have seen, where you look at a picture that's, it can be varying sizes, but you sometimes see posters that are like up to about this big, and if you look directly at them, they're gobbledygook. They're lines, they may have little pictures buried within them, but they're basically just a mix of lines. The trick there is to look through it. And in essence, what's happening, and let me turn sideways to diagram what I'm talking about here. If the picture that you're looking at is here, when you have both eyes focused, you're in focus right at the image itself. What you actually want to do is to look beyond the image, as if the image is not here, but further back. It's very helpful, for instance, if there's a pane of glass right in front of the image you're looking at. Strike a match, don't burn your beard, but hold it close to you, and then actually look at the reflection in the mirror. Because what that does is to focus you behind or reflection in the glass, I should say. So if the image is here and you look through it, what actually happens is, instead of being, and I'll do it this way, instead of being focused right on the image, your lines of sight are actually separated slightly so that they actually come to a point on the object further back. So the point is that if you look through the image rather than at it, what happens is the brain will pick up the fact that there are those two different images superimposed, but they're superimposed in a kind of goofy manner, and you have to separate them by looking through the image. And then what happens is, when the brain picks up the signal, it will in fact fuse them into the object that will jump out at you on that poster. So in essence, it is basically the same process, and what it's based on is retinal disparity. You're putting two different signals into the two different eyes. Another variation on this is what's called relative motion. If you're riding along in a car and you look out at an object out in the field, the object that you look at becomes an anchor point. Anything between you and the object you're looking at is going against the direction you're going. Anything beyond that object is going with you. Okay? So in essence, relative motion there is referring to the motion of objects relative to where you're looking. Again, if it's between you and the objects are going in the opposite direction that you are perceptually, but the objects beyond the focal point are moving with you. That becomes a particularly powerful cue that you and I control, because where we look determines which way the information is flowing past us, and becomes very powerful in anchoring where the object is that we're staring at relative to the entire view that we can see. A minor variation of that is what's called head movement parallax. If you look directly at an object, and as you know, when you're looking at a given object, sometimes you kind of get around it this way, and what you're trying to do is to use the movement of the image to learn more about the image itself. So that in essence, in that case, you're using what's called head movement parallax. And finally then, we're going to look at where these systems actually lie to you. I've showed you several bases for the fact that I'm now going to show you some things that you and I actively misperceive. One example of this is what are called straight line illusions. Here's an example of a straight line illusion. Is the line that is parallel to the ground on top bigger, smaller, or the same size as the lower long line? Is the line on the top as long as, shorter than, or longer than the longer line on the bottom?
It's the same, but the top one appears longer.
Yes, bingo. And the reason for that is that the two cues that you see there on the bottom one, for instance, are the cue that you have when a surface or corner is projecting toward you. If I were standing at a table, or if you're standing at a table, what you've got is the top pair of lines are the two edge lines of the table coming in this way, and the line between the front corner of the table are the two that are coming in this way. So when you've got this kind of an effect, it is a message to you that the object is projecting toward you, that the corner is projecting toward you. When you have this kind of an effect, that's the effect that you get when you're looking at the far upper ceiling corner of the room, because then the ceiling wall line is coming up this way, and the what is it? It would be the wall line is dropping down this way. So you've got this kind of an effect. That is a cue to you that it's a receding or distant corner, and the brain actively misinterprets that. So in essence, what it says to itself essentially, okay, those two lines are the same length, but the top one is further away, so it has to be longer, and therefore we misperceive it. I can, however, demonstrate for you that it is in fact the same length. There's a case where your system is misperceiving it. Having given you that very elegant explanation about projecting and receding corners, I can then blow it to smithereens because the Mueller-Lyer illusion also works this way. If we just hang circles on the ends, and we don't have an explanation for why this works as it does, but it clearly does. That's the same illusion again. It's still the Mueller-Lyer illusion, and the effect is still there if we just do it with circles. So there's a master's thesis for somebody who wants to work out how the Mueller-Lyer illusion actually works. In addition to straight line, we can show you bisecting or orientation illusions. We've got a plethora of those. Are these two lines the same length? This is what's called the vertical-horizontal illusion. And in fact, apparently what's going on here is that if you think about where you're sitting at the desk, if you move your eyes left and right 3 feet, you don't change very much the distance that you're looking. Okay, that is the distance of the object from you is still essentially the same left to right. But if you go the same distance vertically, you're looking at your notes and then you're looking at the far corner of the room you're sitting in. Okay, and so apparently what happens is that the brain, in interpreting this, adds in information again. It causes you to misperceive because it presumes that when you're looking laterally, you're not changing the distance very much. You're not traveling very far, if you want to think about that, or think about it that way. But when you move the same distance vertically, your eye is theoretically moving, covering a much greater distance. And so we actively misperceive it. Again, this one, I will demonstrate for you, is in fact exactly the same length. The vertical-horizontal illusion. Then we can look at a third type, what are called compound straight line illusions. You think I didn't go bananas developing this one. Are the longer lines parallel here or not? And in fact they are. If you don't believe it, lean a pencil up against the television screen to convince yourself, or hold it up in front of your eyes to convince yourself. But the longer lines are parallel. But the interrupting, the shorter lines, the overlay, does seem to interrupt or mess up our perception here. Now put the pencil down because I don't want you cheating on the next one. This is the Zollner figure. Now I want to show you another one. I'm going to start with 4 vertical lines. I'm going to draw a diagonal line on the right side, and now I'm going to give you 5 choices as to which line continues that. Here is PowerPoint at its finest. Okay? I want you to vote by show of hands. Don't cheat. I'll give you the answer. How many of you think it's line A is the continuation of the line on the right side by show of hands? How many think it's line B? Getting anybody? You're voting out in television land too. Line C? Okay, we've got some votes out in television land there. Line D? Significant number of votes, both here and out in television land. How about line E? Which is the actual correct answer. Okay, when we draw it, line E is the actual correct answer. Okay, that's a case where you've actively misperceived, and that's a problem that gives sign makers problems. It's called the Poggendorf illusion. If you have a sign that you're building that has something that goes across it on the diagonal, you've got to be real careful if it's interrupted where you put the two halves. And if you actually go measure it, they don't normally put the second half in a direct linear line. They also don't put it where it looks like it ought to go. What they do is split the difference. But it's a problem with perception that artists have to be aware of. Again, the Poggendorf illusion. And then finally, another kind of compound line question.
Like, I look in the book, it's like E, but when you look at TV, it's just like, I don't know, it looks more like D.
It's a good point that it looks more like D or E or in some cases even C. A lot of what's going on there is the thickness of the different lines. Let me show you the next illusion and you'll see exactly what I mean. These two lines are obviously parallel, but what happens when we put that on top of it? Does it tend to bow outward? And then this one, which is called the herring illusion, can actually be reversed. So that if we cause the fan to go in the opposite direction, the spread lines, the lines now actually will bow inward. I played with this, and I don't have time really to play with it a lot here, but in essence, if you increase or decrease the thickness of the overlapping lines, it impacts how effective or how much bow you see on the intervening lines. So I think part of the answer to your question is that it has to do with the thickness of the various lines that are involved as to how pronounced it will actually be. And certainly, as you can see, when I drew the red line to show you what the actual correct answer was, it's then very obvious what the correct answer is. I mean, it snaps in immediately as the obvious correct answer. So thickness of line, to a certain extent, conveys the actual truth here. And then finally, we can look at various kinds of figure illusions. For instance, is this a square? Yes, it is. The background is causing problems, as it will in each of these for you. Are these two, not this one, are these two figures the same shape, size? And the answer is they are. Yes, they don't look like they are, but they are. And the reason is that normally when you and I judge same size, we line it up either on the vertical or on the horizontal. These are actually lined up on the diagonal. And the net result is then that we tend to misperceive that they are, in fact, actually exactly the same size. This is the Jastrow illusion. Is this a square? This is the herring fan illusion using a square. The same general principles can also be used in the herring fan illusion, which is a circle. Is the inner object a circle? And the answer in every instance was yes. I would not lie to you. These are all examples of various compound figure illusions, which leads us then to another thing. And that is a phenomenon that burdens a psychologist called extrasensory perception. The question is, can people actually perceive items under any of the following kinds of conditions? That is, if we talk about extrasensory perception, is it possible to actually exhibit what is called clairvoyance? And by clairvoyance, what we mean essentially is sensing a message where there is no identifiable physical stimulus. That's one of the alleged forms of extrasensory perception that is possible. A second is telepathy, where we're communicating thoughts from one person to another. A third one is precognition, where in essence what happens is that you anticipate or predict a future event before it actually happens. And then finally, we can also have, well, in fact, let me just demonstrate precognition for you. I have ESP, I must tell you. Okay? And so what we're going to do is use the people in the studio here to demonstrate a rather interesting effect. What I've got here is a newspaper article, and I have printed into this envelope my prediction as to where somebody is going to tell me to cut the envelope. Okay? So what I'm going to do is to ask them to just hold this envelope. I'm going to pick somebody else in the audience, and I'm going to run the scissors up and down the article. Okay? So I'm going to give a hidden person over here the envelope to hold. Don't open it yet. But now what I'm going to do is to pick somebody in the audience here and ask, no, you can stay right there. You don't have to go. This is a seat demonstration. Okay? Holding the article here now, what I'm going to do is to run the scissors up and down. Now I have a tremor, so you're going to have to tolerate me. I will stop and move it up or down wherever you want. But I want you to tell me where to cut this article. Okay, right there? Sure. Okay. You want it at that point, and that's where I'm going to cut it. Okay, now I need to have somebody else come up and pick this up because I don't want to touch it. I want on public television not to be viewed as picking this up. But if you'll just come up and read the line there. You can be opening the envelope in the meantime, and we'll see how close the agreement actually is. Yes. No, that side.
Had their way with the Seattle Mariners this season.
Okay, the first line is all we need. Okay. Had their way with the Seattle Mariners. And what does it say in the slip of paper?
Had their way with the Seattle.
So how did I do that? Did I precognition? Did I know where I was going to be told to make that cut? Skeptics all. No, you can check. You can check the part she has, and there's no way. It's not the same thing printed over and over and over again. For you skeptics, I'll do it again. Who'd like it this time? Who'd take this? Okay. Somebody else, tell me where to cut the article. Criminals held jobs at airport security. Oh, that's a great one to use. Where did my scissors go?
You don't know?
No. Help me. Get out of here. Where the hell did the scissors go? Well, so much for powerful demonstrations. There they are. They were covered over by the article. I knew that. Okay. So much for blowing a good demonstration. Who's going to tell me where to cut it this time? Okay, right there. Right there? A little down. Okay, again, somebody from over there come up quickly and pick this up. You, quickly, we're wasting television time. Come on, come on, come on. And you can be opening the envelope in the meantime. And I guess everybody will be in view this time so that they can actually see it. And therefore just read what's on there.
Well, company hired chemicals to man security.
Okay, and what does it say on the slip?
Company hires criminals to man security.
Okay, smart guys, how did I do it? Because I'll tell you, I don't have ESP. I'm sorry? No, you can check the article. You can check the article.
So how do you do it?
It's a regular, legitimate, genuine, printed the other day newspaper article. Sure it is. Well, of course it is. I would not lie to you. So how do we do it? What advantage would upside down have? I'm a really good psychologist. That's an A. Of course. No, there is a very simple explanation. Do you want to make a guess? There's a very simple explanation, and he's right on it. Okay? Describe to me what the article is like. What's unusual about the article? You need to be on the microphone.
It's all upside down, except
Yes.
for the first line.
It is all the way up to the first line. It's upside down. So what I did was to take this article, cut it right there, right at the start of the newsprint, first just below the first line, and that's the reason that I hold each of the articles this way. So even if you could see the tape, which you can't, it would be blocked by my finger, but the entire article is hanging upside down. So it doesn't matter. I've simply taken the article and rotated it 180 degrees and taped it back. So it doesn't matter where I cut it off. The first line you read, nobody's going to pick it up and read where I cut it. They're going to pick it up and read it right side up. So I know on this one that in the envelope it's going to say, Gone is planning an extensive range of, and so forth. Okay? So, the point is, do I have ESP? Hear me when I say no. I don't, but I can make it seem as if I have ESP. And that's one of the reasons that so many magicians in the world are mad at people with ESP. Because in essence, what the magicians of the world typically maintain is that I can replicate anything you do claiming it's ESP, by simply a sleight of hand. If I can distract your attention, I can do it. Uri Geller, a number of years ago, got a lot of attention nationally about the fact that he supposedly could exhibit what is called psychokinesis, and I've already taken it off the screen, unfortunately. Psychokinesis is the fourth type of ESP, where what you're actually doing is using mind power to bend objects, for instance. And he would make a spoon seem to bend. But in fact, when they put him on the Johnny Carson show, the Tonight Show, many years ago, and in fact switched the box that he'd intended to use, all of his powers magically disappeared. Just simply disappeared. So that in fact, under neutral conditions, ESP doesn't work. There is no statistical demonstration that is convincing that ESP actually
on
works.
live TV? They switched the boxes on him?
They switched them when he could not see. That is, the objects that he'd originally been thought to be working with turned out not to be the ones. On live TV. Yes. And it was. It was a little embarrassing, and then it was just that his powers were off that night. But magicians generally are quite incensed by ESP folks. Go.
Okay, I have a question. You know, like when they do the magician shows and they do the like boxes on the TV and they say go 7 this way, 7 that way, and it always ends up on your box. How do they do that?
What they're doing there is a mathematical trick. There are a series of mathematical steps that you can go through and start with any number, and because of the way they integrate the steps, I don't have a good example right on the top of my head, but in essence what they're doing is relying on certain basic principles of mathematics to reduce to a particular number. But it will work in that way. Give me just a second here to get the next screen up, and then we can plunge onward here. But in essence, the point that I'm making is simply that I can make it seem as if I have ESP, when in fact I'm going to tell you face to face, I do not. I simply do not. And that's the reason the magicians are kind of incensed around the world, that if you've got magic skills, you can do what is normally perpetrated to be ESP. Now, let's jump into the next major section of material, and that is learning and memory. These are the key processes in all of psychology. This is probably the single most important chapter in kind of integrating together everything that we're going to be talking about during the course of the semester. And in essence, what we're talking about here, first of all, is a process called learning. Learning is simply defined as a relatively permanent change in a behavioral tendency that occurs as a result of, and I'm going to put the word reinforced in brackets for reasons that will develop a little bit later here, reinforced practice and experience. Each of those terms is included for a reason. For instance, we include the phrase relatively permanent to eliminate certain things. Fatigue. A football player is good if he can run 40 yards in 4.2 seconds fully equipped. But such a player is lucky to be able to do it in 6 seconds by the end of the game if he's been playing hard. He has not learned to run slower, he's simply tired. So you let him sleep for 2 days or put him down for 2 days and then re-equip him, and he can do it again at 4.2 seconds. So in essence, that's a temporary change, and it does not involve learning. Adaptation, you remember we talked about not being able to feel your wristwatch or your underwear or anything else. That's a temporary change. You wiggle and the feeling is right back there again. Motivational factors like hunger will cause alterations in our behavior, but once you eat, the alteration goes away. Even drug effects. You take an aspirin to eliminate bad feelings, but it will come back when the drug wears off. So the phrase relatively permanent is in the definition to exclude what are temporary changes in our behavior that may occur. We use the word change rather than improvement, because improvement would be an editorial evaluation, and not all of the changes that we learn are improvements. In some instances, they are in fact detriments. The point specifically is that if a kid is acting up out at the grocery store, he has learned to do so, or she has learned to do so, because every time he screams bloody murder, Mom says, all right, you can have it. Mom has screwed up. Because in essence, you're going to have to go through one kind of messy scene where you don't give in, and youngster then learns that you're not going to give in. But as soon as you start reinforcing the screaming, it's going to increase. That's not a desirable behavior. It's certainly not an improvement, but it is a change that you'll see coming over your youngster. Thirdly, we talk about it as a behavioral tendency because not all of learning is obvious. That is, we learn in ways that are not immediately demonstrable in our behavior. Example, you're working with a girlfriend on her bicycle. The two of you go in to have iced tea. She takes in with her the wrench that she was working with, puts it on the counter. The two of you make the tea, you drink it, you talk for 15 minutes, you come back out and sit down. and then she goes through the where's the wrench routine, and she's looking all around for the wrench. Then and only then do you say, oh, it's in on the kitchen counter. Okay? When did you learn the wrench was on the kitchen counter? When you saw it put down 15 minutes ago, not just now when she asked for it. So you have been altered in some way, but it didn't show up until circumstances dictated that you now respond in terms of, I know where the wrench actually is. So in essence, we talk about it as a behavioral tendency, but learning doesn't always show up immediately in your behavioral repertoire. As I said, I'm going to leave the word reinforcement in brackets for now until we can talk about it a little bit more, because it's quite a complex subject. The question is it necessary for learning? And the answer is probably not, in ways that I'll show you a little bit later. But is it sufficient to cause learning? The answer is probably yes. We use the word practice, and by that we do not use the word repetition. That is, we use the word practice because of the fact that there are certain changes that take place that do not involve practice, and they also do not involve learning. I can remember when I was in 4th grade, I had a teacher named Coach. Coach had a whip, and Coach liked to have us climb those big 2-inch ropes that hang from the ceilings in every gym that's ever been built. I could get further up those ropes in 4th grade by jumping and grabbing than I could by actually arm strengthening my way up. Come 11th grade, I had another teacher named Coach. That coach also had a whip, and he also liked to see kids climbing ropes. Imagine my surprise when in 11th grade I could actually go up the rope. What had happened was I had certainly not practiced that in the intervening 7 years. I can guarantee you I hated that activity. But I could do it in 11th grade because I had matured. The ratio of body size to arm strength had shifted enough in the intervening 7 years that I had enough arm strength to do it in 11th grade. That's the reason we add the word practice to the definition, because there are certain other kinds of changes in our behavior that will occur that do not involve practice and are not learned. And finally then, we use the word experience in the definition to handle the following kind of situation. Do you remember the first boy or girl that you ever kissed who was not a member of your family? And you can remember that, and when that event occurred, you did not have to say to that person, I want to do this 5 or 6 times to practice it so I'll remember it. Okay, I mean, that's bizarre. I mean, you remember your first kiss and will forever. Okay? The point is that experience is enough. That is, in some instances, we don't have to repeat things in order to learn them. We can learn it just by experiencing it or living through it. So practice is a way to learn, but it is by no means the only way. And the other point that I should make is that practice does not mean repetition. What it means is actually cognitively engaging with the material. Because I have students who come up to me and say, I studied and studied and studied, and I got an F on your exam. And the problem there is that what they did not do is learn and learn and learn. Mere rehearsal does not produce learning, which is a mistake that some people think. If I say it over and over again enough, I will learn it. No. You have to intend to learn, and you have to focus on it cognitively in order to master the material. And that's what's meant by practice. On-target practice is what's necessary for learning to occur. Now, to put this in a context for you, I want to set it up as an intervening variable. And in essence, what I'm going to suggest is that learning actually has a number of different independent variables which will lead to learning. Repetition is one, with the proviso that I gave you a couple of minutes ago. Being active is another way. Behaving, any of the words that are listed there, practice, training, observation, experience, all of those will lead to this condition that we call learning. But we don't see learning. Learning is an intervening variable, okay? We do not actually see learning. We know the conditions that lead up to it, all the things that are listed on the left there. And in turn, we can measure it in a variety of ways in terms of various dependent variables which are impacted by learning. Behavioral changes, amplitude of response may change. The latency or speed with which you give a response may change. How often you do a response may be altered. And in fact, what is called resistance to extinction, the ability to blot out the response, will differ depending on how well it was learned originally. So in essence, what I'm going to argue is that all of these factors anchor learning in an external way so that we can study it. But we never actually see learning. Learning is an intervening variable. It is anchored to the external world in terms of the independent variables which we can manipulate to cause learning to occur, and it's anchored in terms of the dependent variables, the things that are altered when learning occurs. But we never actually see learning. Like the example I gave of hunger much earlier in the course, This learning is an example of an intervening variable. And in order to study it, as psychologists, we have to externalize it in some way. We have to bring it out into the world that you and I can manipulate and watch things happen. Now, let's also distinguish learning in a couple of different ways. I want to distinguish it, first of all, from performance. And what I mean by that is illustrated in the following kind of a maze. I'm going to talk several times here over the next couple of lectures about what is called a T-maze. This is an example of what a T-maze looks like. Can you figure out why they called it a T-maze? He wonders. Okay, so this is a T-maze. The standard features of a T-maze are the following. It includes, first of all, a door, a gate at the bottom end, which defines what is called the start box. And in essence, what we do is to put some food cups recessed into the floor up at the ends of the arms of the T. The reason they're recessed into the floor is because rats are smart enough, if they're being rewarded only in one alley, that they'll go to the corner and look to see where the food is. So in essence, we recess it so that they have to commit in one way or another. And the importance of that commitment is illustrated by these lines that I hope are going to occur here in a minute. There we go. We're putting a rat in the start box there. And in essence, we're going to define an error as occurring if he puts his front feet past the projected sides of the maze there, where the red dotted lines are, dashed lines. If their front paws go over that, that defines an error if they've tipped into the wrong alley. So we've got food on the right there. What we're going to do is actually open that door. Interestingly, you never raise the door, because a rat will follow something that's rising. You pull it to the side, and then it's out of their way, and they will then rush forward. That's a hint for better living you can drop into a cocktail party if you want later this week. This rat has stepped beyond the dashed line and therefore has committed an error in this particular situation. But in essence, it's on this kind of a maze that this data was collected. And in essence, what they did was to run 3 groups of rats under 3 different conditions. And let me focus on this graph with you for a couple of minutes and point out some things. First of all, group 1 at the top basically got no food at any time. That is, it didn't matter which way they turned in that T, there was simply no food in the cup. And yet, they would spend time wandering around the maze. But what happened was that the likelihood, the number of errors that they made did not change very much during the course of the experiment itself. They dropped slightly, but they stabilized, averaging around 6 or 7 runs per trial. 6 or 7 errors per run is what I should say. There was a second group that always got food. That's the line that drops and actually continues to drop all the way through the experiment. It would have been nice if they'd continued it a little bit longer, because it would have eventually done what is called asymptote. It would have flattened out. But in essence, on this graph, the food group did in fact run with greater accuracy. That is, steadily got better during the course of the experiment, because every time they made a correct turn, sometimes they were turning to left, sometimes to right. There was a cue like stripes or a different color or something like that that was always randomly flipped from side to side, and they could learn to turn to that cue, and the food would always consistently be there. That group's performance got steadily better and better and better. The third group is the one that is of interest relative to my demonstration of performance here, and that is the group that got food only after 10 trials. So that group's performance on the first part of the experiment pretty closely replicates the group that never got food at all. In other words, their performance improved a little bit, but just showing all sorts of signs of flattening out at about 6 or 7 or 8 errors per run. Okay? Now on trial 10, they get actually it's trial 11. They get their first reward. And look at what happens to performance on trial 12. Now all of a sudden they are running even slightly faster than the group that has had a reward all along. Okay? The question then is, had that group learned or not? We're going to come back and look at that a little bit later, but the basic point is that their performance is altered when the food is added. Do you want to then argue with me that their learning has been altered? Well, in fact, only one thing has changed, and that is that they've gotten that food. They now all of a sudden know when they come out that start gate, there was food there last time. And now what happens is, instead of just kind of meandering around and sometimes going left and sometimes going right, they are now paying attention to their environment, and they're turning correctly to the cue just as well as the group that has gotten the reward all along. The point that I'm making there, and the distinction that I'm drawing, is the difference between learning and performance. What's demonstrated here by that third group is that sometimes when we learn, it does not necessarily show up in our performance. And it's only when we add that food that in fact the performance now begins to reflect the learning that clearly has already gone on in that rat's head, if you want. Interesting that their performance actually is greater on the group that didn't get food and later did. That caused a lot of consternation for a long time among psychologists until someone finally pointed out that what that group was running with was frustration. And the likelihood is that they ran down that alley a little faster because they knew that food wasn't there sometimes. We'll pick it up next time at this point.